Okay, once again we're here. This time solving the exercise related to the hybridization model. First of all, as a review, we have three types of hybridization models. Either you're thinking of as SP3 and SP2 or an SP hybridization. In short, SP3 is meaning that you have four hybrid orbitals that you're using in order for the carbon atom to make four identical hydrogen bonds. This is resulting in a tetrahedral structure where you have four sigma or single bonds, and the angle that you will be having in between the hydrogens or the substituents, whatever they are, the radicals in this structure, it's going to be of 109.5 degrees. If it is the sp2 hybridization, in this case, out of the four hybrid orbitals, you're only using three hybrid orbitals, and you have a pi or pure electron. Okay, this is meaning that you have three sigma bonds and that you will be forming a pi bond, resulting in a trigonal planar structure. This is related, don't forget please, to having double bonds, and you see that each one of the carbon atoms on the plane are forming this triangle. Okay, and the angle in between the two radicals that you would be having for each of the carbon atoms would be an angle of 120 degrees. Okay, for the SP hybrid model, this is meaning that out of the four hybrid orbitals, you're only using two of the hybrid orbitals, and that you have two pi or pure orbitals. This meaning that you're having or that you're making two sigma bonds and two pi bonds. This is when you have a triple bond. Each carbon atom is forming two single bonds, one, two single or sigma bonds, and two pi bonds. The geometry of the structure, as you can see, absolutely a linear planar structure forming an angle of 180 degrees. This is a review of the hybrid orbitals, and remembering also this important issue. If you have a double bond, let's analyze only the double bond. This double bond, how is it built? How is it formed? Because you will be having this carbon having its three single bonds, just like the other one. It's three sigma or single bonds. And for each carbon atom, you're having in a perpendicular plane to the plane where the triangle is being built, you're having a pi electron that will be meeting in space to this other pi electron in order to form the double bond. Okay, so what am I trying to summarize here? Whenever you have a pi bond, this is made of two pi electrons. And When you have a triple bond following this very same idea, let's give a color into this. You have one single bond for this carbon, two single bonds for this carbon atom, two sigma bonds. The very same thing goes for the other carbon atom. Perpendicular to the plane on the y-axis for both carbon and on the z-axis. You're going to be forming a bond here, and you're forming a bond here. The two pi bonds. If each pi bond contains two pi electrons, and you have now two pi bonds, this is meaning that you have four pi electrons. Is this clear? If so, let's open a new note. Okay, so as to complete the information about the structure shown on the image. Okay, this is, they're asking for carbon atom number 1 in the structure. I'm sketching it out here. This is a CH2, which is bonded to two other things. Look at the image on the right of my screen, where you have the CH2. Okay, this carbon atom is forming four single bonds with another carbon, with another carbon, with hydrogen, and with a hydrogen. What hybridization model is responsible of making us understand the structure for this carbon atom? You're having an sp3 hybridization model. Number of sigma bonds on the following column to the right in the table, you're having 4 sigma or single bonds. On the following column, you were asked about the number of pi bonds. In this case, you have no pi bonds. All of the bonds are single bonds, so you have no pi bonds. How many pi electrons do you have? You have no pi electrons because you have no pi bonds. And what's the geometry of the structure? It's a tetrahedron, or a tetrahedral structure in which you find the carbon atom in its center. Okay? And people, for the carbon atom labeled as 4, I'm not taking into account the answer that you gave because it could be a little confusing for all of us. This is carbon atom number 4, which in the image is attached to a CH. Sorry. This is carbon atom number 4, which is attached by means of this double bond to a CH2, and which is making a double bond to a CH, given the label of carbon atom number 3. Okay, why am I saying that this is a little confusing? If you check the structure of that carbon atom 4 in space, no wonder, it's absolutely having a linear geometry. What turns out to be a little confusing is that you have a double bond. And we had learned that whenever having double bonds, this is going to be explained by means of using the sp2 hybridization. But in this particular case, if we are meant to understand the structure, the geometry of the compound, this carbon atom number 4 forming a linear structure out there in space, the only way of really explaining its structure would be by thinking of the sp hybridization model, in which the carbon atom is making only two single bonds, two single bonds. So this bond and this bond that are making the double bonds, and which could also be explained by means of having a triple bond, this carbon atom is having a pi electron here and a pi electron here in order to make a double bond over here and a double bond over there. So I repeat, little confusing. This would not be appearing like this in the exam. It's not the idea to make it, you have troubles there at the exam. This, as the correct answer would be, as related to the hybridization model, it's being explained by means of using the sp hybridization. Number of sigma, what am I doing? Sigma bonds, you have 2 sigma bonds. Thinking about the number of pi bonds, you have 2 pi bonds. Number of pi electrons, you have 1 from this carbon atom and 1 from its neighbor. So you have 2 over here, and you have 2 other pi bonds, 1 from this carbon atom binding to this carbon atom. So in total, this amounts as 4 pi electrons. And the geometry, as I was explaining a while ago, it's going to be having a linear geometry. Don't you worry, I'm not taking this exercise into account in order to give you a grade. I'm giving you, if it's the case, the 10 points for this exercise, even though you might be answered this section wrong. Okay, don't you worry. Moving on,